Hey, we're live.
We're live, Alan. Hey, everybody. Thanks for joining us for part 2 of Information Management in the Post-Pi Era. I'm Jeff Nepper, my fearless partner, Alan Ray, and we're joined by the crew that you met last week, Dawid, Ken, and Leonard. Hey, guys.
Morning.
Jeff,
Yes.
what's the difference between a piano, a tuna, and a bottle of glue?
We need to ask Ken this because I'm already in the know.
All right. What's the difference?
Couldn't tell you. Enlighten me.
You can tune a piano, but you can't piano a tuna.
The glue?
Yeah, a lot of people get stuck on that.
That was a polite giggle from Lenny. I can tell when Lenny actually laughs when he's polite. Hey,
That's an intellectual joke.
Was that what that
Jeff.
was? That was intellectual. Yeah. Okay, fair enough. Hey, my wife and I celebrating 12 happy years of marriage this year. Thank you.
Wait a minute. You have kids much older than that. I thought you.
Well, we've been married for 20 years, but
yeah, happy. You missed the happy part.
Happy.
Yeah.
I was previously married. I tried to remarry my ex-wife, but she figured out I was only after my money. All right. Are we ready to kick off? We've got live audience in front of us, and we are going to do something a bit ambitious today. We're going to try to put 2 weeks of work inside of 2 hours. In order to accomplish that, I'm going to suggest, Alan, that you and I get the heck out of the way. So we're going to jump right into it. If you were with us last week, you saw us work through the following 3 parts of the project: data connectivity, data logging, and data modeling. So we used software toolboxes, OPC router, and data hub to demonstrate how we could bring in flat files like CSV or XML, how we could do web scraping. I think we were grabbing some live data from an Alberta power utility where they were listing their current pricing. We talked about legacy equipment using tools like a Opto 22 Groove product to take legacy PLCs or current IO and bring them into an MQTT environment or expose them as OPC on an OPC server. We even demonstrated how we could do that a couple of different ways. Once we had them in a standardized format, then we said, hey, now look, I can use Canary and I can do some data logging over OPC or MQTT. Even if I still had to use OPC DA, I could convert that to UA to get to a safe, secure standard. And then from there, we showed how we could abstract the names that you might be stuck with from logging into more user-friendly naming or a standardized naming structure using virtual views. That's Canary's modeling tool. And then Lenny demonstrated how you could templatize an information model, write rules around how you're going to create that structure, do it over like an ISA 95 or an 88 structure, and deploy that. So that's where we came in. We did all of that in an hour and 45 minutes with a lot of questions along the way. Now, what are we going to cover today? So if we look at our architecture from last week, the gray is what we've already covered. We've connected to source over on the left, brought it to a standardized format, used Canary Sender Service, brought it into the historian, have done an abstraction layer with flow on top of the historian. And now today we're going to turn that raw data into actionable information. We're going to cleanse it. We're going to contextualize it. We're going to carve it up into aggregated KPIs based on event process. We're going to group things together by asset and run calculations based on those assets. And then we're going to distribute that information a bunch of different ways. Both Canary and Flow are going to be responsible now for creating a hub of accessible information. We're going to expose it using a tool from Dawid and Software Toolbox as an OPC UA server. We're going to push it to Snowflake, to SQL, to the UNS. We're going to put it in front of clients or in front of our customers over HTML dashboards. And we're going to expose it on demand via API. And as I mentioned, we're going to do it all in the next hour and 55 minutes. So with that, there's our road. And are we ready to get going?
And we're off.
Okay, so who's up first?
I believe I am.
All right, Ken, do that little screen share thing and
Yep, present, share my screen. Let's find the right window. That's always a challenge. It's really a challenge because it's
meanwhile,
not.
I'll get Ken in the driver's seat. This is how we get the technical hurdles out of the way for the day.
Oh, there we go. Now it appeared. Okay.
There we go, Ken. I got you.
Everything's good. Okay.
We can see it.
Yeah. So last time we quickly covered kind of what Canary can do with our view service. Since last week's session was such a hit, we only had operations in BAMP Flash last week. The demand has been unbelievable, and so we actually had to expand our operations. And so if I go and look at our global Maple view that I built around BAMP just really quick last week, we've actually had to expand into the US now. So now we have operations in Canada, US. And so we kind of flushed out and built out some additional facilities. We have some additional simulated data coming in. And so what can we do with that now? So now that I have this global Maple model in place, I'm going to quickly demonstrate some of the capabilities of our calculation server and how, when you have asset models, how you can generate a single formula and scale that across all your assets. So if I go into calcs and events, very quickly, I'm going to just demonstrate a couple of the pretty common ones that we get asked to do. So let's do a Maple average temperature. And again, I'm going to target the asset model that we have built out that covers our Canada and US operations. And I'm going to do this across my evaporators here. So our global model now has 14 evaporators. I can actually see a list of my asset instances down here. I can see the ones that are in Canada, the ones that are now in the US. And if I look over here on the right side, we have all kind of available functions. A lot of these are OPC-based functions. Some of these are, custom, proprietary to help you compute, various computations that are required for operations. We're going to stick with something that's very common. So I'm going to look for my time average, and I'm going to pull it over here. And so what we're actually looking to do is do a look back over the last hour and just compute what my average temperature is for each asset. So this is something that's pretty common. Before I do that, if I want, I know that I have some data that goes back a little ways, so I want my calculation to cover that time frame as well. And when we're setting up these calculations, we can determine set if we want to do this every time the value changes, or if we want to just do this on some periodic schedule. So in this case, I'm going to say I want to do this calculation every 15 minutes. And now I want to go choose basically which tag is going to be computed. And if I go to my asset tags here, so based on the model that we've created, here are the tags that are available for my evaporator. And in this case, I simply just want to pull the temperature in. And I think I missed my quotation. Let's get that right. And we're going to do this over 1 hour. I can quickly do an evaluate. I can see, for the asset I have selected here, here's what that would currently evaluate to. If I choose another site, I can see the value is going to change. And now that I'm satisfied with the expression, I'm going to go ahead and output this to a data set that I've already created. And since we're doing an asset-based calculation, we have some special syntax here to do substitution based on the pathing of each asset. So I'm going to use my %asset%, and I'm just going to simply call this average temperature. And if I go ahead and say apply, I already have my backfill set. If I come out here and say close, If I filter down so my list isn't as jumbled, it's easier to see. I can go ahead and put this in live mode. We're initializing, and we should quickly go to backfilling, and we're going to go ahead and fill in 2 months worth of data. While it's working on that, I'm going to pop back in here real quick, and I'm going to do another calculation called what we call roll up. And this is where we allow you to do some aggregation of child assets and build a computation at a parent child or at a parent level. So in this case, I'm going to use my global maple once again, and this time I'm going to go up to what we were calling facility. So I can see my facilities are Alberta Banff, Alberta Grand Prairie, and then 2 facilities in Colorado. For the sake of time, I'm going to go ahead and just quickly go ahead and start typing in what my roll-up is. I do have some cheats over here to make the process a little quicker. So I'm going to path out. Again, I'm targeting my global maple, and I'm targeting the asset here. And in this case, I want to just pull in maybe the average of my mixer levels. So I'm going to compute these on a aggregated level and roll those up to a tag at my facility level. So again, I need to output this to my data set with my special syntax. And this is going to now be average level. So there's other possibilities when we're doing roll up. We can do, so if I filter down here and just quickly show, we can do summations. We can do counts, averages, minimums, and maximums. So if I wanted to compute, maybe the maximum at the same time, I can have multiple expressions that will output multiple tags for me. So now I'm doing maximum with a maximum level tag, and I'm also kept my average with my average level tag. If I were to do an evaluate, it's barking at me because I forgot to set this to periodic. Thank you. And again, we'll set this to 15 minutes, and we'll go back and quickly backfill this as well. So now if I do an evaluate, now I'm good. I've got all my steps set, and quickly do an apply and a close, and we'll kick this one off. While this one's kind of computing and doing some backfilling, I did want to show that we now have a new tag that's going to be part of our model called average temperature. If I quickly jump over to Axiom and I want to do a browse of my model just to show that those tags have already made it into the model. If I go to my evaporator, here I can see an average temperature. If I repeat that for another one, again, average temperature exists. I didn't have to do anything inside my model. My model is already set up to be aware of my calculated data set because of some things that Lenny has already been pushing to Canary. And so without any effort, without any pre-definition of tags in the historian, without any work within our model, those tags automatically showed up and have been reflected out to the user tools that are available. So that's kind of Canary Calcs in just a few minutes, just a quick overview to show what's possible. We also have the ability to, of course, generate events off of that data. But we just wanted to demonstrate how quickly and how easily some of these calculations can be built upon asset models that you may have in place.
Thank you, Ken. Well done. Let's so we've just seen 2 different types of calcs, review for the audience. A running average, now minus calculating, updating as the values update, and then asset additionally to that. That was included as asset-based, right? With that opportunity to also roll up. Love it for the idea of total volumes across tanks, total average capacity or level, I should say, rates. Very helpful. Lenny, you're up then now to cover our data cleansing. Any questions that came through, please, audience, for Ken, drop them into the chat on that side of the calcs. We'll address them here in a bit. And Lenny's going to get us kicked off now on how to take this data from Canary, from other sources. So remember, we're talking about combining data from multiple sources, bringing it together, and adding rules and governance around how we're going to treat that data. Lenny, you ready?
Yes, thanks, Jeff. All right, so we're back in the Flow configuration environment. Just to show where we left off from last week, we instantiated a template for our evaporators, and we used that template to then instantiate two pieces of assets within my model here. So I've got my evaporator 1, and I've got evaporator 2 now configured within my model. But before we use the data that we get from these different data sources, we might want to first clean the data before we actually use it in our KPIs or in our aggregations going further. Right, so how can we do that? Well, let's look at my data sources here. I'm connected to a Canary historian. So this is the historian that you just saw Ken creating those views and those calculations on the assets. And the cool thing about what we do with Canary is we expose the views within that Canary historian. So there's the base view, the Canary historian view. If I expand this, it will show all the raw data sets that's available in that historian. Remember, we are pushing data from David into these BMR, Banff Maple Reserve data blocks. But what Ken has done for us is he's kind of stitched everything together from those different data sets within the views. So here's my global Maple organization. As we said, we expanded from Canada into the US as well. So there's my 2 regions. And then if I expand this, I can see all the tags that's been stitched together by the view. And there's the average temperature calculation that Ken has just done as well. All right, so let's have a look at my calculations or my temperature here. Let's look at the raw temperature tag that's coming from Canary. So if I double click on this, it will query the data and it will give me the raw data that I've got from Canary. Again, remember, Flow does not store this raw data. We merely pull that data so that we can have a view for the engineer, what that data looks like, what outliners potentially does he want to remove, so that we can build the calculations based on that. All right, so here's the raw data. I'm going to keep it very simple for today. All I want to do is remove a little bit of outliners. All right, so let's say everything below 63 degrees, I want to remove, and potentially anything above 66 degrees, I want to remove as well. So a little bit of a band filter that I'm going to build on top of this data here. So I'm just going to expand my model here just to show you guys how we can do the tag filters. So I'm just creating a model here in my model for tag filtering, creating a metric here just to build these filters on top of. And then what I'm going to do is I'm going to take the raw temperature tag from Canary. I'm going to drag that across into my model. And again, remember, this is going to now create my abstracted layer. So this is going to be my actual temperature that I'm getting back. And what I can now do is I can take the temperature tag and I can drop it onto this little calculation icon. So when I do that, what we do within Flow is we create a calculated tag. All right, still based on the raw data. So this is going to be my bands filter. And I'm actually just going to move it in the hierarchy that it sits underneath the actual tag there. All right, let's open up this calculation. Again, it will automatically add the tag for me that I'm going to use within this calculation. It's going to bring back that raw result again for me in here. And if I expand the retrieval, I can actually now go and build a calculation based on this. Now, a value that we get from the historian will always have a value time, a timestamp, and a quality component. And I can use all 3 of those, the value, the quality, or even if there's a string value coming back from the historian, I can use all of those components within my calculation here. So quality we will use to filter out bad quality. If it's not good OPC quality data that we're getting back from that historian, we potentially would like to filter that out as well. We're just going to play with the values today. So I'm going to just build an inline little if statement, and I'm going to say, you know what, if the value is greater than 66, that's what we said. This is just inline ifs in a C# notation. So I'm asking the question, is the value greater than 66? Let's replace it with null for now. So I don't want to have any values greater than that. Else, well, let's look at the value again and say, well, if the value is greater than or less than 63 in this case, then also replace it with a null. Else, just give me the value as it is. Right, validate my calculation here and refresh my calc, and this will then eliminate values that's above 63. Let's just put this in a little bit better view for you guys. So let's go for the past 2 hours here, and let's bring in the original tag. So let's bring in that guy. Let's just maybe change its color here so that we can actually see it. There we go. And let's do this. I changed the wrong color. Hey, let's do that and do that. Cool. Sorry, let me just change the width a little bit. There we go. There we go. That's what I was after. All right, so now you can see the original tag, which is the blue tag, and then the red tag is the tag that we filtered. So all of these points are now below. But this isn't great, because what does this do? It actually creates maybe gaps in the data. So what if we replace the tags that I want to outline with another tag potentially? So why don't we use Ken's little average that he's built, he's running average, and instead of replacing the values with a null, we'll actually replace it with the average tag. So I'm going to do that again. I'm going to add this tag into my model. This is going to be my check meter kind of tag. So this is going to be my check meter there. And now what I'm going to do is I'm going to refactor my calculation a little bit. I'm going to bring in the check meter into the calculation expression. And instead of replacing the value with null, I'm going to replace the value with that average. So I'm going to replace it with my little check meter there. Refresh that, give it a refresh there, and that will then go and refresh the data. And now instead of the null, I've got the value of the check meter. So let's go back to that data source preview window that I've got here. Let's refresh this data here. And if I do that, then you'll notice that the red lines will now be filled in with the average temperature. So if I take the check meter in there, put it onto the screen, you'll notice that that follows the yellow line, what the average was. So that's quite cool. I can then mix and match these different tags. I could have mixed and matched these different tags from different data sources. And I can create real complex calculations to filter out and to replace my data even before I use it up into further calculations and aggregations going forward. Cool. Jeff, I think the next thing that we're going to do after we've done this is now to create a little bit of context surrounding our batches that we're getting back from our process plant.
That's right. So we want to now we've got at the historian level, we've got calculations running in real time, adding more context, more information. Lenny's demonstrated how we can start to cleanse this data. And we need to also just comment, remember the goal of this exercise is to meet the standard that Pi had already set for information management, and then to elevate the solution beyond that. So the flexibility, for instance, of being able to bring in data from multiple sources, to write cleansing rules, to govern those rules, to standardize it based on templates and apply it across all of our data. The ability to do all of that and not only rely on a historian to do it. It's one of the things that we're saying, hey, look at the benefit of being able to do it this way. And now, to Lenny, to your point, yes, it's all about event contextualization. I think we're going to target here batch and quality, as well as we're going to reach out to some SQL databases and get some reference points from some non-time series data. Accurate?
Perfect. That's correct. All right. So let's have a quick look. I'm just going to close this edit here in the middle. And let's have a look at the template that we've got back from the enterprise. So remember last week we pulled down this template for a base evaporator. It's got our state engine for that evaporator process. It's got my different inputs, my temperatures, but I'm missing something here. If I look back at my data, I can see that I'm getting back the batch ID. I'm also getting back the quality, the percentage salt, the percentage sugar. So all of this data that I'm getting back now from the database, from David's CSV scraper, all of that data sits in the historian as well. But I also have a LIMS database. Okay, now what the LIMS database does, it's a little SQL database. And inside of the SQL database is my upper and my lower specs for my different checkpoints. So if I'm checking for sugar, I know what my upper and lower spec limit is. And if I'm checking for salt, I know what my upper and lower spec limit for the salt is. So the idea is now to marry all of this together to give context for my evaporators. Okay, so let's see how this is going to go. Now, the great thing about the templates is that if I pull a base template from the enterprise, I can actually extend that template with site-specific measures. So in this case, they did not give me a batch tracker, right? So I cannot track the different batches that's been sent to the quality department. So what I'm going to do here is I am actually going to go and create a new event on my template, okay? And this is going to be my batch tracking event. All right, I'm just going to call it batch for now. I'm going to use the same rules that I used when I instantiated my previous templates to create the nice naming conventions. And I'm just going to reuse this on this batch and just to rename that to batch as well. Okay, so I've got my event for my batch. I need to be able to trigger that event. Well, I don't have an input for the batch ID as yet, so let me do that. So I'm going to create a new tag. Again, I'm expanding my model, and this is going to be the batch ID that I'm getting back from the Canary Historia. Excuse me. And let's quickly configure this batch ID as well. I'm going to go to my data source. I'm going to go to the batch ID there. I'm going to drag it across, and this is now going to reference that batch ID that I've got within the solution. Cool.
And Lenny, if it wasn't in Canary, if the batch was coming from a SQL database, you'd still do the same thing.
Same thing, and I'm going to do that for our spec limits. You're going to, and I'll explain to that later. But yes, I'm going to create another 2 inputs for my upper and my lower specs, and I'm going to do it exactly the same way with tags. In that case, I'm not going to connect it, but I'm going to write a little bit of a SQL script to get that data out. Okay. So let's trigger this event. I'm going to trigger this event every time that the value of the batch changes. So that will then create a new batching event. So calculating event frames or creating event frames based on the tag of that batch ID change. All right, what else do we've got? We've got obviously the batch ID itself. So I want to know what that batch ID is. So I can add metadata to my events as well. In this case, we call them attributes. So I can go and create a whole bunch of attributes that I'm going to associate to the event to even add more context. In this case, it's going to be retrieved from my historian, and I'm going to retrieve the batch ID, and I'm going to drag the batch ID there to associate what the actual number was that I'm getting back from these events as well. Okay, so that's kind of sorting my batch event frame out, but I also need to get my specs. So I'm going to create 2 more tags, maybe 1 tag just to show the point. Let's just pull in my upper limit spec here. And let's create a little, again, it's a tag. This case, I'm not getting it from the historian, I'm getting it from my SQL database. So I'm pulling in my SQL database, and now I can write a query to retrieve that data. Got my little cheat sheet here, so I've already prepared this query just to save time, but let me paste in that query there for us. All right, so now I've got data from my database. Let's extend this batch here to add a new attribute. And in this case, it's going to be my upper spec. And let's add my upper spec with my upper spec tag. So now I know what the upper spec line is. So you can see the more attributes I add, the more context I would be able to add to my data at the end of the day. And then obviously we need the actual sample, so the upper limit of potentially the sugar and the salt. Let's just do one. Let's just get the sugar in here. So that's going to be my sugar content. And the sugar content is also coming from my canary historian. And that is going to be underneath my data set or my view that's been created. I can go and add the sugar content. So there's the sugar content that's available as well. Right, so let's make one more attribute on this batch, and let's call that my sugar percentage, sugar content, and then we're going to add that, linking that to the sugar tag that we've got here. Right, so triggering data from Canary, getting spec limits from SQL. So we're starting to mix and match all of these different data sources. But when you actually look at it from a template perspective, I don't care if this comes from SQL or from Canary, whatever. We've all normalized the data. From this point forward, when I work with it in Flow, I don't actually care where that data is going to come from. We will normalize that data and we will create the context for that. Perfect. Right, let's release this template. So you notice we've got all these little yellow dots. That means I'm still working on my template. Let's release it so that it's now active for production. And now on my model side, I will be able to actually, you'll notice there's these little blue dots that's related to the instances of this template. Blue dots means there is actually new information available. So I can go and update this guy. And when I update this template, it will pull the work that I've built on the template here, and it will go and create all of those different components on my instance level. So there's my batch. If I expand that, here's my new inputs, my state, my sugar, my upper limits, and all that's left for me to do is to go and deploy this. Okay, while that's running, let's update batch 2 as well. And I've added now that additional context to it as well. So that's quite cool. Let's see if this worked. So it's going to go and backfill. There we go. There's all my batches that it triggered. And if I'm lucky, it's going to pull back these values for my upper and my lower specs and for my batch ID, and it will populate those in there as well. Okay, so let's just give that a minute, and then we see if we get our context available as well for that. So that's how I would create a batch. I will pull back the data for that, and I will see what the resulting attributes is for that particular batch in the system as well.
Lenny, while we pause and wait, a question came in from Isaac. Wanted to know, can Flow software help in the management or visualization in the asset template of tags and hierarchy?
Sure. I think I need a little bit more explanation on what he would like to visualize. But what we do is, obviously, we will create these templates based on the asset. And yes, there is visualization within the tool where I can now take this event frames and these batches and then present it in a visualization form. So we are going to build some visualization back on that as well. So there we go. There's my batch numbers that's pulled through as context. There's all my sugar content. And then there is the upper spec limit that I've pulled through as well. So now everything is contextualized within the event frame kind of concept. Perfect. All right. Now, how do I use this? How do I potentially create a KPI that's going to use this contextualized information? I don't know. Let's say potentially I would like to know how much power that I use within this batch run. So I've got an input
That's going to reflect my power usage. But again, the enterprise template does not have a metric for me for power. So let's quickly build that out. So I'm going to create a new metric here. This is going to be my power metric. And again, I'm just going to steal my little naming convention that I've got here, just to replace that name. And this is going to be my power. And let's create a hourly power KPI. This is going to be my 1 hour kilowatt usage. Right, let's open this up. Currently, it's set to be a manual point. I don't want it to be manually entered. I want to retrieve it from a data source. And again, I'm going to go through my inputs here and just drag my power down in here. Okay, now I would like to go and create a aggregation of this. The power tag that I'm looking at is a lifetime totalizer. So I can't average that. I can't do a time-weighted average on that data. I would like to create a counter aggregate. So that will then tell me minimum point, maximum point, and what is the total then for the hour. But it will also count for rollovers. So if it did roll over within that hourly period, we will automatically handle the rollovers as well. The context will be based on the current calendar. In my case, I've got a production calendar. Flow has the capability to manage calendars, where I can now go and say, you know what, let's look at my hourly KPI or my daily KPI. What constitutes a day? Well, a day is from 6 to 6. But what I can also do is, instead of just the context of the calendar, I can also go and add context of my events. So in this case, let's look at the total for the batch as an example. So let's do that. Let's add the batch as context as well. And I would like to see it in the context of the batch ID. Okay. Doesn't make sense to look at power for sugar percentage or power for upper spec limits. That doesn't make sense. So I'm not going to add these as context to that as well. Just the context of the batch ID so that I see what is the total usage of that per batch. Okay, let's release this guy. And let's see if I update my template here. It should go and create a new power metric. There we go. There's my hour with the context added already for my batch. So let's deploy this out as well. While that's running in the background, we can do some cool things here now as well within my template. I can say, you know what? I would like to know what is the contextualization, not per the batch. What about the shift? So because Flow has a capability to define those calendars, I do have the concept that I can go and create shift patterns. So I can go and create in this case, a very simple morning, afternoon, night shift pattern. And I can go and say, you know what, it's as simple as if I want to know what the shiftly value is, just drag my hour to my shift. And this is going to be my shiftly KPI. Let's just add that nicely within the model here. Again, drag the hour onto the day for day, and that will be my daily total of power usage. Let's take the hour and drag it onto itself. And this is going to be a shift to date, so a progressive total. Drag it again. There's going to be a, oh, sorry, that's the wrong. We already have a shiftly. Drag it again onto the hour, and that will create a day-to-day progressive total. So we can create all of these different time frames of how we update the data as well. Release this and update my little power metric here, and it will go in and inherit all of that. I just need to map it to the correct batch because I've got 2 evaporators here now. Update that, and there we go. Shiftly, daily, and all of those are ready for me to deploy as well. So the Flow engine will do its thing. It will go and get the data for the hours, but very importantly, it will also go and get me the data for the batch ID. This is quite cool. So now I know exactly for the batch runs, how long was that run and what was the total usage for power for those. These batches aren't very long. They're like seven minutes, but here's a nice long batch, 2 hours almost, and that's the amount of kilowatts that we've used. So it's a very efficient process that we've got going. But anyway, I've got then the context of the event with the batch ID associated to that as well. So that's quite cool. What else can we do? Well, what if I would like to know potentially where am I going to end up at the end of the day from a progressive total? So I've got my day-to-day total of energy usage. So you can see how I'm progressing through the day. What if I want to project this maybe into the future to say, you know what, looking at the past, I don't know, 3 or 4 hours, and we look at the rate of energy consumption, where am I going to end up at the end of the day? So let's do that quickly. I'm going to extend my model again on the template side. I'm going to take my hourly measure. I'm going to drag it onto the calculator here. And this is going to do, what I'm going to do is I'm going to create a moving average. Okay. This moving average, I can now say, you know what, don't just look at one particular value for the past hour. Let's look at a whole range of values. So I'm going to look at a range, and I'm going to look at, for the past 4 hours, I'm going to look at what that value is. And then in my expression here, I'm going to go and say, you know what, look at this array of values. And I would just like to do the average of that data. And that will then give me a moving average. Cool, so I've got my moving average. Let's project that moving average into the future. So I'm going to drag it onto the calculator here as well. And I'm going to project this data. So this is my moving average projected, moving it nice into the hierarchy. And I just want to project it for 4 hours there. And I'm going to just look at the last 4 hours value. So this is going to be a previous value, and that's going to be the last 3 points there. Cool. Let's move that in, pop that into there, and validate the calculation. Now, based on this projected value, I can now very easily go and create a shift to date as well as a day-to-date projection. Just remember to project these guys into the future as well. So let's do that. And let's release this as well. Again, I'm going to get an update on my template. If I release my metric there on the power, update that, map it to the correct batch, evaporator 1. And there I go. There's my moving average. Let's deploy that. Again, Flow will do this all in the background. It will go create a moving average calculation for me on the engine. So there we go. There's the moving average. If I'm lucky, it would have gone and projected that moving average into the future. Okay, so it's busy, still busy doing that. So let's just give the engine a little bit of time to do that. And then we'll see what my projected value is looking at. Let me just see if this, yeah, that's correct. Okay. And after that's done, we will see what that looks like and then what my projected day-to-date and shift-to-date totals are.
Lenny, do you have time to take a question while you wait for the engine?
Yeah, sure.
Okay. Keith is walking through the challenge of having remote assets and trying to centralize that data. And those remote assets are spread out across multiple time zones, potentially multiple Canary instances. What do you recommend as a best practice in Flow if you're running a centralized Flow system on managing data from multiple time zones?
So Flow will store all the data within Flow's database in UTC based on a general timestamp that you select for that. What I would probably suggest is you're probably going to go and create more than one calendar to handle that within that central instance. And depending on the calendar settings, it will then utilize that to then show the data in the different formats for that. So you'll probably end up having a calendar per kind of region that you will configure, and then utilize it that way. And
then some of those regions, well, most of those regions will have daylight savings time if he's in the States or Canada. And how does Flow handle daylight savings time? Do you do a 25th and a 23rd hour?
Yes. So we will do a 25th and a 25 hours for the one day, and then 23 hours for the previous day. So we handle that automatically within Flow. Yes.
Okay.
Okay.
And thank you.
Yes. All right. So one mistake that I did is if I want to project my value, I need to be able to project the event as well. In this case, I cannot project my event. So I'm just removing the batch context from my projection. Else I can't move forward with my projection. So that's the only little mistake that I've made. But there we go. So there's my projected day-to-date power consumption. So I know for at 1 o'clock this afternoon what is the potential that I'm going to hit from an energy. And obviously I could have projected that further into time, but that's how I then can project into the future using a very simple little moving average of the data going forward into the time as well. Okay.
Perfect, Lenny. Do
Cool.
you need a quick break? You've been going for 25.
Let's share this data. I think that's the next step.
Yeah, let's take a quick look. We'll let Lenny take a drink. So look, guys, we've gone through the entire left side here. Now, obviously, Ken and Lenny are just demonstrating the capability of the technology in very small pieces. But hopefully what you're seeing is the scalability of the demonstration based on the fact that the rules that Ken wrote, it wouldn't have mattered if he had 1 asset or 100 assets. Ken, just out of curiosity, some of the counts of assets that you've seen inside of Canary of a similar type of asset?
Oh, thousands, tens of thousands in some cases. You know, we deal with some really large oil and gas customers that are approaching 18,000 oil wells. When you start talking renewable and you start talking battery systems alongside those, and you start counting the number of cells and batteries, I've seen 25, 30,000 asset instances on items like that.
Yeah. Yeah. And what's great is, just for the audience that may not be familiar, Canary's all written in .NET. Or operates in .NET. So that means you've got the full processing power capabilities to keep up with those types of asset counts and the calculations associated with them. And then of course you've been seeing Lenny working from a template, which means whether he's got 2 evaporators or he's got 20 or 200 evaporators. I think Lenny, you recently ran some templates for a college basketball March Madness tournament that Neomatrix hosted, and you were the engine, and you had hundreds of templates of people's predictions that you were working through.
Correct.
That's right. So this will scale, but you can probably, as the audience, see how quickly you can actually bring it together. And that's one of the huge value adds, I think, that's being put forth by this group of technology. Okay. We're ready to talk about now shifting. We've got things calculated. We've got new information. It's got context all over it. Now it's time to start sharing and being a hub. And this is really, I think, where this solution is really going to differentiate itself, in the fact that it's going to be extremely easy to stay interoperable and share this out to other platforms, other databases, other applications, particularly now under the AVEVA badge, right? That's one of the things that we've been talking about, is with the acquisition of OSI under AVEVA. Now all of a sudden it's like, well, welcome to AVEVA. You're going to be using AVEVA tools. And this is all about staying interoperable across multiple platforms. So what we're getting ready to watch is Lenny's going to now identify some SQL databases that need this information and match their schema and publish to them. He's going to talk about taking it to a cloud application like Snowflake, as well as publishing back to the unified namespace and get this information back into Canary. Why back into Canary? Because you very well have operators looking at real-time trends on screen that might want information like projected values in 2 or 3 hours as a resource. And then Ken is going to demonstrate, yeah, hey, guess what? Or at least talk through, we can also get things that are in Canary, like this new running average or these asset rollups, back into the UNS. From there, we'll visualize, and then we'll start showing how this becomes an information smorgasbord using the APIs. All right. Lenny, back up to you, bud.
All right. So if we look at my data tab here, the data tab, I've showed you guys, I can now add data sources into Flow. In this case, I've used the Canary and the LIMS or the SQL database to get data into it. Just to show you guys, there is a whole whack of connection capability that we can add to get data into Flow. We can even buffer the data from potentially an OPC UA source as well to get that historical range that we need. I also have this concept of a consumer. Think it develops a data sink, a consumer of that data, a piece of application that would like to get this data out of Flow. We call them consumers. What do we have available from a consumer perspective? Well, as Jeff mentioned, we've got SQL-based consumers. In this case, I'm going to show how to push to a Snowflake database in cloud. We can push it back to Microsoft SQL databases or even an Azure Event Hub. I can put it on a AWS Kinesis stream or even a Kafka stream. That's quite popular these days, is to put it on a Kafka stream, and then whatever technology wants to read off that Kafka. And then, as Avi mentioned, we can also push back to the Canary store. Okay, now I have created 3 of these just for this demonstration. So obviously Canary. I'm going to push back to Canary, push back to Snowflake, and then push to MQTT local as such. All right, so let's edit my Snowflake connection. You can see it's red. It's not happy. So
Lenny, can I pause you just quickly? Ask you to check your mic input. Make sure that you're not on a laptop mic because we're getting some bad feedback. Triple ellipse on your individual user down at the base.
Just cancel the screw share, else it's going to.
Sure. Oh yeah.
Infinite.
Yep. While you're doing that, JC asked a question. Hey, how many Flow instances do you need? Is it one by site or just a centralized instance? That's a great question, and it depends. If it's a medium to large operation, a traditional facility, it's a one-to-one pairing. And if it's remote facilities, small facilities, there's nothing in the Flow license that restricts you from bringing multiple facilities under one instance. You could build several calendars under that instance and manage multiple facilities. It's more about ultimate number of calcs and resources available. JC, maybe shoot Lenny an email. His email's pinned at the top of the chat, and he can give you some of his advice.
Cool. Is that better?
We'll see, I think.
Okay, cool. All right. So my Snowflake database connection is pretty empty. I haven't entered all the information that I need to make a connection to Snowflake. I did supply my password. So let's just look at my little cheat sheet here. So this is my account name. So let's fill that in. And let's fill in the host or where that Snowflake host is residing. And then let's quickly have a look here at Snowflake itself. So this is Snowflake. You notice I've got a database here called Flow. So I'm going to push the data into this Flow database here. So let's fill that in. So my database name here is Flow, and then I've got my username that I'm just going to quickly copy and paste. So that's pretty much all you need to then connect to Snowflake. I'm going to save this connection. Notice that it is red. The reason why it's red is I need to assign it to a platform. So the best practice within a Flow deployment is to always have your collectors and consumers as potentially as close as possible to the data sources. So we have this capability where I can go and deploy it. But there you can see it brought back the namespace of that Snowflake database. So there is a data integration table. And then in that, there's a whole bunch of columns that I can push the data into. So you now have the freedom to write your queries in such a way to match any table definition within Snowflake. Okay, so if we look at my database here, there's my data schema. And in that data schema, I've got this integration table. And it's got the entry ID, period start, and period end. And then it's got a variant, which is a measure object that I can then push out a JSON blob to store within Snowflake. Let me just run it just to show you guys there's no data currently within this. So we're going to populate some data with it just now. Right, so that's all I need to get connection to Snowflake. With Canary Historian, it's very similar. All I need to know is where does my historian live? This is quite cool. We're pushing to a cloud-hosted Canary in this example. I'm pushing to that global Maple Calcs dataset that Ken is using and mixing and matching within his views. The only requirement that we need from a Canary perspective is that your sender service is also installed on the same node. So we're pushing that data through the Canary sender service. Why is this cool? Well, it will then handle store and forward for me if a connection goes down to that cloud-hosted solution as well. So I've got my...
Let me just point out for the audience, that's also the security handling. You might have noticed that there was no username or password with Canary. Canary manages permissions between sender and receiver internally. So that makes that even easier for you at this point, right?
100%. Cool. All right. So if I go, I can do this in two ways. The best way is obviously add it to my template. So let's look at my projected hourly measure here. And what I would like to do is I would like to push this value out to these providers. All right. So we've got this integration tab here. And now I can decide, do I want to push the data out in its hourly context, or do I want to push the data out based on the batch information? Okay, I'm going to push it out to the production calendar, so I would like to get that hourly information out as well. Just because I broke the link by deleting these the batch from my instance, I'm just going to do it on this instance level right here as well. All right, so I've got my projected values here, as you guys can see. I'm going to go to my integration tab, and it is as simple as dropping these consumers onto the tab here. So let's do Snowflake first. I'm going to drag the Snowflake onto that production value there. And notice now that it will give you the capability to go and write your different queries. So again, as I said, you are in control of the schema. I'm not going to push comments or user data. I just want to push the values for now for this demo. Flow does have the capability that you can add comments to any data point. Think about a little bit of annotations. But for now, I'm just going to insert the values itself. All right, so I've already prepared this little query here that's going to insert it into that data block. So let's do that. I'm going to paste it in there. And I'm going to deploy this integration. Right, so what this is going to do is going to backfill. So it can also take the historical data that we've already configured within Flow. It's going to backfill that. It's going to push it out. And it's going to send that data into my Snowflake database. So it's busy backfilling, getting that data and pushing it out. So if I'm lucky, and it's probably going to take some time to do. Yeah, there we go. So there is my data. Period start, period end, and then there's this little JSON blob where I have all the data available for that, and then there we go. There's the value of what that projected value for that point in time is going to be. So that's cool. So I can send it to Snowflake. Let's send the exact same thing to Canary. So I'm going to take the Canary historian. I'm going to drag that onto the production calendar. We've got a tag that we've already created here that I'm going to use. So I can specify a specific tag within Canary that I can push to, or if I left this blank, it will use the hierarchical name within the Flow model to go and create a tag for us within Canary as well. Okay, and again, I can push the values, or I can push the comments as well, so that we add it as annotations within Canary as well. In this case, I'm just going to add or to push the values. So let's deploy this one out. Let's look at my sender here. Currently, I'm pushing one tag. There we go. I'm pushing two tags now, and it's pushing out that historical data. So Ken, you should start to see those values coming into that tag as well. And then obviously every hour, as there's a new value, we will start pushing this data out as well. And then just like I did the previous ones, I can now push it to a broker potentially. If you want to kind of utilize the UNS concept. In my case, I've just filled in very simple connections to Mosquito, and I can push the exact same data out to a broker. So I can drag that into the production, deploy it, and it will send the exact same data now to a MQTT broker as well. So that's how we can share it with all of these different consumers, and push that data out to then all the other applications that might want to utilize this data.
Perfect. Thanks, Lenny. Ken, are you seeing anything on your side that we can take a look at? And maybe also if you could discuss how we could bring information from Canary to a UNS, that would be great.
Yeah, sure. So I've been peeking on the server as Lenny was setting that up, and I could certainly see the new tag arrive with the projection for the 1 o'clock hour Eastern time. So that's there. I could.
Could I ask you for the good old screen share?
Oh, sure. Let
Now that
me.
you're all pro on it.
Yeah, let me find the right place to do that. So I will present again. I got to find my right window. And this is going to be weird because I'm sharing where I'm in. Okay.
I've got Axiom. Is that what it was?
Yep. Okay. So if I jump to, so I'm in my historian view here. So here's global Maple calcs that Lenny is pushing to. And I actually at the very top, I can see his power projected. If I choose that, I can see, I go back 1 day. And so here I can see the values that he has projected. I can see it's going into the future here, just as his calculation has shown. So
awesome.
Yep.
And now, can you walk us through a little bit about how Canary, the mechanism Canary would use to take, for instance, your 5-minute running averages or your asset calcs, or maybe even large data sets of data and that might arrive at an enterprise Canary that needs to be shared to a UNS?
Sure. Yeah. So we have what we call our publisher service. So we've actually demonstrated that and spoke about that previously on other Integrate Live sessions. So if you want to go back and watch the history, but basically our publisher allows us to publish out any of the views that we have created on the system, or any subset of those views, or any even particular data sets potentially. So lots of times if the data that we're receiving is already being consumed by Canary through MQTT, then if we're doing any additional calculations on that, then lots of times we're just publishing back out the net new tags that we are creating within the UNS. If we happen to have data sources coming in from non-MQTT sources, then we can contextualize those, build a nice asset model, and publish that out as well. So our publisher is pretty flexible. It's Sparkplug compliant. We can also publish out JSON as well. So if your client doesn't speak Sparkplug, we can push to a broker just through JSON. So it's pretty flexible. It's pretty full featured, and you have the flexibility to choose what you want to push out within the UNS.
Awesome. All right, doing a time check. We are in good shape. We're 55 minutes remaining. We've got 50 minutes of content plus Q&A. Ken, will you kick us off on dashboards and reports and show us how Axiom could be leveraged for asset models and for diagnostics, please?
Sure. Yeah, I guess I shouldn't have stopped my screen share so quickly.
No, you can, but now you just have to fill in there.
I was a little hasty. Okay.
Yeah, there you go, bud. All right, go for it.
Okay, so I've already authenticated to the live instance that we've been working on here, and so I want to go ahead and in this case I want to start a new application. So I have a blank slate, and what I want to demonstrate is some of our asset capabilities within Axiom. And so the first thing that I'd like to do is demonstrate what we call our asset templating. So I have a blank screen. I'm simply going to drag this control onto my screen. And right away it pops up and asks which model do I want to target, for this control. So of course I'm going to stick in my global maple that we've been talking about, and I'm going to look at all my evaporators in this case. And if I hit apply, it goes out to our view service, queries the view service, and quickly comes back and recognizes that we have 14 of these assets. And I can see right away, I get kind of a little panel or a card for each one of these, and with the name of the asset reflected within each card. The nice thing is, let me do some quick screen adjustments here so it's sized a little more appropriately maybe. Whatever I do to one of these cards is going to be echoed on every card. So if I resize these so I can get the layout to fit a little nicer, now I can start adding some controls. So the first thing I'd like to do is pull a grid onto my display. And there we go. I got it to highlight, pull that in, do a little bit of resize. I don't want to cover my labels here. And let's pull maybe a label into here, and we're going to say this is our level, and I want to grab the value box that equates with that. So it knows the context and the template that we've built for an evaporator. So when I go to add a source tag to my control, I'm presented with a list of tags that are part of the evaporator template. So if I choose my level, it's going to give me the current value for that level. And okay. And so now if I maybe, let's resize this a little more. Maybe I want to look at, whoops, sorry about that. My mouse is not cooperating. So now if I drag in another one, I'm going to choose my level again, but now instead of current value, maybe I want to do some quick aggregation on this. So I want maybe my 1 day. We understand all the relative terms, so you can do M for minute, H for hours, D for days, W for weeks. And I'm going to scroll down and I'm going to choose the good old time average 2. And I want to be maybe day minus 1 day. And so now I get a value of what my average is for that point over the last day. Okay. And if I come out of design mode, I have an issue. Boy, it's fun doing things live. There we go. Okay.
You were in the header.
I was in the header, yeah. So that didn't work out very well. Okay, so now that I got my controls placed properly, I can see that what I've done has been echoed across all my cards here. So I can quickly, let's go to grid row. We got some shortcuts down here. So I have my whole row selected. I'm actually going to just quickly copy that so that I don't have to worry about dragging controls. I can just simply come in here, do some quick updates, and repoint this to my temperature. And so I can see all the other parameters have stayed. I'm simply just retargeting. So now I have my levels and my temperatures. Some things that our asset templating allows us to do is, this is extremely powerful when you have hundreds, maybe even thousands of assets. I could certainly sit here and scroll through and we will actually show paging if I have more assets than what we will permit on a page. But how do I get maybe ones that need the user's attention in front of them a little easier? So maybe I'm concerned with ones where my level is going to be dropping below some point that I consider critical. So instead of looking at all my assets, can I put an expression in to simply get the assets that meet a condition in front of the user? And so in this case, I'm looking for my assets where my level's less than 35, and quickly we filter that down to the 4 assets that meet that condition.
Hey, Ken, I got a quick question for you.
Yep.
Thinking about dashboarding, one of the issues I've always had with dashboarding is people tend to put a lot of data on a dashboard that's irrelevant, doesn't actually drive action.
Sure.
I'm assuming if you wanted to do something like this for a dashboard, you could hard code that so that anytime this came up, whatever those actionable items were, those are the cards that show up.
Absolutely, yeah. In fact, you could have this set. I would say something that is extremely common that I work on with my clients is something to the effect of we will actually put a series of actionable buttons at the top of the screen. And so maybe this one is going to be labeled low level. Maybe this one would be labeled high temp. And then through just a little bit of scripting, the user can click on the button and it's actually going to change the expression that is inside the asset template. And the user then doesn't have to understand or know how to use the syntax within this either. So we've pre-built conditions, and they can simply choose these buttons, and the grid or the template will adjust on the fly automatically based on the predefined conditions that we've put in place. And so that's been a pretty powerful use case, and keeps the people out of having to know, exactly what the tag names are and some of the nuances of the syntax in here as you build this out. And what we would actually do is take and actually hide the template so the user's not even aware of what's going on. And so through buttons only, we're controlling the assets and getting the ones that need attention pushed to the top of the grid for the user to take further action on them.
And Alan, to Alan's point, also that concept of just because you're limiting information on the front card doesn't mean now that the user doesn't, once the action is clear that they need to investigate, now you could link out, right, to a more diagnostics oriented screen that has the next piece of detail.
Good segue. I was actually just getting there. So lots of times we like to call this, a summary screen or an overview screen. But, as you can see, there's only a single value here. So this doesn't really tell me a whole lot, like how long has this condition been occurring or what was leading up to this condition. And so what we can actually do is we can take our labels that represent our assets here, and we could turn those into a nice link. And based on that link, we can actually pop out to another screen potentially. So knowing that these are showing a list of my evaporators, I quickly started a second screen over here, but I want to set the context of this screen to an asset as well. So I'm going to go in, again, choose my model. And in this case, I'm going to choose my evaporator. And just for examples, we'll start with the first one in the list. And maybe I'm an old school guy and I love my trend graphs. And so I'm going to do some quick resizing. And I'm going to pull my trend graph in here. And I'm going to say, okay, I want to add in my level and my temperature, and maybe I want to know, when this thing's been running. So by default, my preferences are an hour. I like looking back much longer than that. Maybe I want to go back over a week. Maybe I even look even further back. So now I have 30 days. I should put in another label here so I can prove which asset we're looking at. And so now if I go back to my overview screen, I see an asset that is troubling to me. I'm going to go ahead and pick Pikes Peak East. And as I choose this, if I get out of design mode, if I choose this, now I can see the context of this screen has changed, and I'm now looking at Pikes Peak East. Same thing if I go back, Mesa Verde South, and again, the screen's going to refresh. Now, if I'm on this screen, maybe I don't always want to come from the overview screen. I can see I have this little icon up here, which is what we consider our asset picker. Lots of times people don't like extra clicks and having things that aren't visible. So if I go out to my screen, I can actually make this be inline as well. So now that I'm on this screen, I could easily switch context very fast. Going through this, we actually have buttons to do previous and next. We have some industries where people are doing, for instance, a well review daily. And so they have the wells that they're responsible for, and they can very quickly just bounce through and get a quick visual of what's going on with their process. So that's kind of asset templating in 5 minutes.
Good.
We're trying to keep this brief. Of course, Axiom has a lot more features. We're known for our trending. We've been doing trending for a long time. There's all kind of resources we have online. If you're interested in learning more about Axiom, you can check out our YouTube channel. You can check out Canary Academy. We have Canary Bootcamp, which would walk you through some of this as well. So yeah, we have a lot of resources. This live.canarylabs.com is actually a hosted environment. You can come in here and actually play with Axiom with the data that we're logging, as well as some other data that's being simulated to give Axiom a try.
Yeah, I've just dropped again in the chat a link that they can come into that sandbox and use. Okay. So copy that link and pin it for later. Lenny, let's pop you. Sorry, Ken, 1 second. Let's pop Lenny in, and Lenny, you're going to give us the second half of the visualization, some dashboard reports with some event timeline and event context, batch context.
Yes, thank you. Let me do that quickly. Ken, if you don't mind, if you can just share that screen as well and just send me the URL for that work that you've just done. Let's quickly present here, and let me show you how we would be able to visualize our batch information. So let me just get my sharing up. There we go. We should be up and running.
There you go, Lenny.
Perfect. All right. So where did we end off? We ended off pushing our data to our consumers. In this case, the Canary historian was one of those consumers. But I would also like to visualize this maybe as a report or as a little dashboard within Flow. Now, Flow has a Flow server component that hosts all our internal dashboarding and charting requirements. And I'm going to use the model that I've already built to just visualize that within Flow. The way that we do that is with our chart capability here. So I've got charts that I can build. Currently, there's no charts whatsoever within Flow. So let's create a new folder. This is going to be my BAMF folder. And within BAMF, I'm just going to go and create a new folder for my batch information. So let's create a folder there. Sorry. And let's go and create underneath BAMF a new dashboard. Okay, so this dashboard is going to be my batch dashboard. And if I open this up, I'll have a clean little piece of canvas that I can then go and add a whole bunch of different types of charts. So what do we have available? We've got ability to add event-based charts. So obviously we've played with batch events in this scenario. So I'm going to focus a lot on our event-based reporting that we've got based on that batch data. So I've got a timeline. So the timeline is just going to give me a visual representation of how my batches progressed through time. If I double click on the individual components on the dashboard, it will give me the capability to edit the title. So let's give it a nice title here. So this is going to be my BAMF EV001 batch timeline. And I can now add different sections into my report. And in this case, I would like to visualize the batch event. So I take the batch event from my model and I drag it into the event section here. All right, so it will add the batch with all of its different attributes. And then I can specify and say, you know what, I would at least be able to see it for the past day or the past week from an initial load. So let's do from a whole day moving start to current. So it's a moving window that I'm going to look for batches in this case. So that's my first report, a little bit of a timeline. And then let's add a secondary report component here as well, which is my base table or my event-based table report. And if I double click this, again, the same kind of scenario, I can have, this is going to be my batch report. And from these sections, all I have to do is drag in my batch report here. Again, it will add my batch ID, my upper spec, my sugar. But what I can also now do is I can add what is the total power usage for that entire batch. So I can add that measure or that metric component to this as well. Again, let's look at the past days worth of batches. So I'm just going to make this a moving start to current value, and that will give me that component. So that's all that I have to do here. If I go to my browser, this is the kind of the front end within Flow. No charts as yet because I've created them from scratch now. So all I'm going to do is I'm going to just give my page a reload here, and I'm going to have that little information that I've built within my band folder. I've got my bash dashboard, and if I select that, it will go and load my little timeline of my batches, and then also give me my little batch report with all the batches and all of that context within one another. Okay, so I can see what my batch is, I can see what my batch ID was, the upper spec, the sugar level, all available within this timeline. I can zoom into the individual batches here to see a little bit more detail. Currently, they're all the same color, so I can change that color to represent my individual batches potentially. So let's do that. So let's go back into my timeline here, and instead of using the color, let's use one of my attributes, in this case the batch ID as the color. Refresh that, and there we go. I've got the colors now separated by, or my batch separated by my individual batches. Cool, so I can identify my single batches. One thing that I can also add to my batch report here at the bottom is a little bit of a Gantt, like a waterfall timeline of my batches. So I'm going to add a Gantt header here, and I now have the capability to also specify a different color for my Gantt. But if I just refresh that, you'll notice that I've got a little bit of a Gantt timeline that specifies how long these different batches was, how did they run, so I can easily identify a long running batch or the smaller individual batches as well. If I want to focus on one batch in particular, I do have these filter capability where I can go and say, you know what, I only want to look at batch 5 and 6 as an example, and it will then filter based on that on the front end as well to focus on the different batches that I've got. And I can go select all of them, or I can just go and select all of these batches as well. Not yet as fancy to filter on a range, but we're getting there to have the capability to also filter these based on values. In this case, all my values are the same, but I can go and specify and look only at a certain batch content, which in this case, let's look at that 95 guy that was a 95 there and see, oh, that was on batch 21. So I've got a little bit of filtering capability on the front end as well to visualize my batches as well. We also have the capability to embed a web page. So let's resize this. Let's add a little bit more space here, and then underneath my components, I have the capability to embed a web page within the front end as well. Ken, I don't know if you've got a URL ready for me.
I do. I put it in our chat.
Right. Sorry, it's going to look a little bit weird because I just need to copy. There we go. Thanks, Jeff. So let me just copy the URL from Kenya quick. All right, so we're back in business. Thanks, Jeff. All right, so in the web page section here, I'm going to go to my link, and I'm just going to paste that URL. Sorry, let me just do that again. Paste the copy, and let's paste that in. So there's the link to Ken's URL. And now if I refresh my website here, it will then embed that Axiom page within my screen as well. So there we go. There I've got Axiom, log into that. And there is the little screen that Ken also built. So I can see all my live values as it's coming in. Look at my overview here for my trending, my real-time trending that's coming in as well. So there I click on the details and I can see my real-time trends as well. If we spent a little bit more time on matching the background colors and everything, it would have matched quite nicely. But the point is that we can create this composite kind of page dashboard with mixing and matching the technologies of the vendors as well.
And I think maybe, Lenny, just to point out, not to demonstrate, but based on your menu options, by your navigation options through your menu, you could have just dedicated a full page to Axiom or multiple pages to Axiom.
Correct. The other thing that I could do is I can pop out these individual panels. So I can pop out this, and then it will launch that whole Axiom in a new pop out, and then I've got the nice big screen all available to see all of that data as well.
Perfect. Okay. Anything else you wanted to cover? Or does that get us through?
That's it.
Overviews. Things just to point out to the audience. Other capabilities within the Axiom wheelhouse that you didn't see demonstrated: symbol graphic libraries. I bring that up just from the kind of the old school Pi process book views. If you wanted to try to build out more SCADA type screen visualizations with piping and more of a process map, you can do that in Axiom. Although it does seem like the industry is finally starting to move away from that a bit, thankfully. But just like OPC DA, it's still probably prevalent in 70% of the operations. Let's talk now about flipping to the last part. How do we start sharing all of the information more ad hoc or as needed? And David, you're going to kick us off, and we're basically going to demonstrate, I believe, how you can use an API that's exposed like Canary or Flow does, and then present that information from an OPC server. Accurate?
Okay, so we can do that. Look, I'm not going to go into the actual details of the API on either Canary or Flow, but Lenny and yourself can obviously, and Ken can attest to that. So basically what the use case is, let me see if I can share my screen, which is not going to work. So we're going to say share screen. So just bear with me for a second, entire screen, and we are going to go to the mighty OPC router, which is now showing. So basically the use case here, so we're back to kind of, in my opinion, it's the full circle we've done now. We've started last week with connecting, sending to a historian, analyzing from the historian. We've seen now we analyze the data, build dashboards, etc. But I always say, being like Jeff rightfully says, we're the data plumbers. I always say, what about the poor operator? What is the interface that the poor operator in the control room use 90% of his time? Is his HMI or SCADA screen? So it's great to have single panes of glass with trends and analysis, etc. But we need to also somehow bring information back into the interface, which is the SCADA or the HMI, that the operator spends his time on. So what I just want to illustrate very simplistically is kind of saying, well, how do we use a tool like OPC Router? We've seen last week how we're using this tool to convert content of CSV files that's being spit out from laboratory systems and convert that to OPC items. We've seen Data Hub, which is a different product, scraping the website. Now, if we do the same thing, as Router also has the ability to suck from APIs using a RESTful interface and convert that data. So I want to just very briefly go through this and kind of take you through the elements of how do we configure this, and then see if we can get some live data. So firstly, as we said, we need to create a REST client. So what you guys can see here is that I've pointed to the Flow API, which is hosted by Lenny. and there's a few authorization bearer tokens, etc., etc. So this is easy. It's straightforward. I can go much more clever in terms of changing what my login strategies is, etc. But for now, we keep it like that. Secondly, what do we really want to do? We want to suck out of the API, and we want to literally convert what we've given or what we've received into OPC tags for the SCADA system to consume, or the alternative is we can just kind of manipulate existing OPC items that's sitting in a top server or a Kepware or other OPC server. So we've got two options. So I thought, let us just do this slightly different than just building it. So what I'd like to also just illustrate, since I'm a lazy person by nature, is to kind of say, look, if there's more than once that I'm probably going to use this, let me build a template. So basically what we've built here, and I'm going to go through this in detail, is to kind of say, how do we read from the REST client, which is Flow, but it could also be Canary for that matter, make that call, take that, and then split it out in variables. So literally, we have this REST client object, which again, from a drag and drop perspective, it's literally just dragging over. I'll go in there and just kind of say, look, we pointing it to the connection we've just made. I can also make the host dynamic and give it some dynamic parameters. And then we have a very specific endpoint, which contains the Flow instance ID, etc., etc. And that's exposed. And I'm sure Lenny is going to show that later. There's a very interesting Swagger-like interface on top of this API that allows you to play around and do some tests. And we're obviously doing a get component. So as part of the parameters that we pass as part of the request is we need a start and an end date. If we keep it empty, it kind of takes the default last hour or something like that. I'm not 100% sure. But then also there's the concept of either a tag ID or a template ID. And Lenny, keep me honest here. We are using template ID because that means, yeah.
100%, David. So we are wanting, we don't want more than one API call potentially to get the tags back from Evaporator 1 and Evaporator 2. So instead of giving David, we do have that capability where you can still ask for individual tags data, but instead we are going to give David the template ID for the temperature or the power or whatever the tag is that we've created. What that means is David only have to run one command, REST command, and we will then look at how many instances did we derive from that template, and we will pack all of that real-time data for those instances back in the response so that we send back both for Evaporator 1 and 2 and not just one of the tags within that Evaporator.
That's spot on. So I mean, that's basically it. And then we obviously limit it because we don't want to run this forever. So we can test it from within this testing environment and this template creation environment in OPC Router. So I could go say, look, I'd like to pass 21 because I know that's working, and say send. And coming back, I'm just going to do a Control-A quickly and paste it into Notepad. That's literally what Flow gave back to me. Now, this is a massive JSON payload, obviously, that you need a library to understand. So we're not going to worry too much about it. I'm just going to move that aside for now. So we know it's working, it's querying, and it's giving me something back. So I'm going to cancel that out. The next step in using OPC Router standard functionality and transfer objects is to literally say, look, we have this new object called JSON transform, and it's based on the concept of what they call JSON Nata transformation expressions. So literally, I've pasted in that example in terms of what we've just received. And then I just do a little transformation, and with a beautiful help from ChatGPT, it makes it really, really cool. And you can see, well, it just transforms the object because I don't want all the unnecessary stuff. I literally just want, give me the name of the first evaporator and the value, which is the temperature, and likewise for the second one. So if I can go, and I'm just going to do this, I can go manipulate that and say, well, values, then it gives it in a different format, etc. For now, we just do this JSON Nata expression. And then last but not least, I would take the JSON Nata expression, which literally is that payload output, which I'll copy. I take into a read object, and I literally just say, there it is, paste it in. Please suggest to me the different attributes and values, and I literally just add the functions and say, look, I'd like asset name, value, asset name, and value. And that is it. So if I now have this function defined, or this template defined in OPC router, I can literally go say, look, create an instance. We're going to give it a nice name. So we're going to call it ID number 21, just to, and if I can spell number correctly, and we can say, look, we took it from that template and we're going to just put it in the main folder. And the magical number here is 21, but there might be some other templates also if Lenny had some other templates he could give to me. So if I say create and I go to my instances, I've got ID number 21. You can see it's populated 21 in terms of the variable that it's passed. And I can just say make the changes productive. And if I go to the productive changes, we're going to either wait 10 seconds or I can just manually trigger this. And it fires off and it says, pass 21 to the Flow API, do the call, get the transform, do the transform, split out the whatever I've received from the transform and split it out in variables. And these variables are in actual fact in variables that's served out by the OPC UA server that's built into OPC router. And that way I can get any SCADA system, HMI system, plant control system to subscribe to these tags and use that for operator displays, for alarming purposes. And if you really want to be adventurous, you can even start manipulating set points in the controllers like the PLC and the DCS. That's it in short of converting all these really cool stuff back into a language that the control system naturally could understand.
Just to call out the fact, David, you used a template ID, created one flow, and if there was 50 evaporators, and you now have 50 evaporators on that server.
That's correct.
Highly scalable. Well done.
That's it in a nutshell.
Yeah, and it's amazing how many times we don't actually see information that's been processed come back into the OPC landscape. And so really nice. Again, it's almost like your puns. You're creating that that POD unified namespace on top of OPC technology. Well done. We've got API review, Canary and Flow next up. Who's taking the lead first?
I'll go.
Okay.
I guess.
Okay, Ken.
All right. So let me share once again.
We've been timing you every time you try to do a screen share, and you've been trending faster.
I'm getting better. I've learned the clicks. I'm like a trained mouse here. Okay, so what I've done initially is I've actually just browsed to the online help. So I've addressed the same cloud server that we've been going at. I put in our secure port, and here's our help documentation around our API. I'm just going to be working with the web layer that sits on top of our API. As Jeff had mentioned earlier in the episode, we are mainly a .NET shop, so our core views API or read API is actually at a .NET layer. And we have helper assemblies if you are interested in integrating at that level, which is exactly what Flow is doing. But for most people that are well versed in scripting languages such as Python, R, you name it, JavaScript, we do have a web layer that is extremely performant. And just as our data collectors on the front end that we talked about last episode are unlicensed, our API on the back end is also unlicensed. So there's no additional cost to be able to utilize this. And it's a full-featured, fully functional API. Our own tools are actually built on top of the same function calls. So we're not hiding or obscuring anything here. You get access to all your data. There's different sections that we have in our API. So obviously there's browsing, data. I'll go over get tag data 2, which is what most people, of course, are going to utilize. You can actually make subscriptions and have a live interface, to get data updates as new tags or new data is arriving in the historian. And you can also kind of interrogate the asset models that you've built, and as well as any events that you may be generating. We'll just focus on a couple of the methods today. So I can see right now I've targeted help. We're going to start at the node level. And since I'm actually on the server, I can actually copy the URL from here, and let's paste this in. And of course, it's a secured environment. So I need to supply my token that I've generated from my user account. And if I paste that in, now I can see all the models that are created on the system. So we have our default historian view, and then here's our global maple that we've been talking about. So if I wanted to drill into this a little bit, I could simply add a variable that we call path. And you can see I've already done this in this browser. So instead of typing it all, there's global maple. I can see our Canada division and our US division. Now that's not very exciting. So let's actually get away from nodes and see if we can do some browse tags. And since I don't have anything sitting at the root level, of course, nothing returns. So simply by adding another parameter called deep, now I get back the entire tag list that we've been talking about, and that is echoed out inside our model. Maybe for this demonstration, I actually want to filter down a little bit. And so I want to build kind of a dynamic search here. So I want to say search. I only want my BAMF sites. I want my level tags for my mixers. So it's kind of like a Google search. You can put in any fragments of the tag paths that you want. And if I do this now, very quickly, I come back with just the 3 tags that meet the criteria. And the reason I wanted to filter down is let's start requesting some data based on this condition now. So instead of browse tags, I'm going to quickly do get tag. Well, if I could spell, Dahlwood's rubbing off on me. Get tag data 2. So without putting in any other parameters, it's honoring the same search that we performed during our browse tags. So instead of having to pass in an entire array of tags or maintaining that list, so maybe your system is ever expanding and new assets are arriving, but you have outbound data integrations. By doing something like this, where it's kind of dynamic and not maintaining a static list of tags, if BAMF would add another production line, this query would recognize that and return that in the future without having to go back and change any API integrations that you have. So out of the box, we're going to get the last value that the historian has recorded. And so it looks like we got something at 1241 for each of the tags. If I did a quick refresh, the time has updated to 1242. So very quickly, those are coming back. But maybe I wanted, instead of current value, I need to actually get back some larger record sets. So I did do a little bit of pre-work here rather than you watching me type out a gazillion characters. So here's something that is requesting the live data since we started our episode today. And so for each tag, I can see I now have a whole series of values coming back for the call. And it was quite responsive. I don't even know how many hundreds potentially we returned. Lots of times when you're working with data, of course, the raw data is not going to be the desired effect. There's some systems that iterate better with normalized data. And so we call that processed or aggregated data. So I've preformed another URL using the exact same search criteria. This time, instead of getting back all my raw data, I'm going to ask for a 15-minute average. And so if I do this, I can see I now get a normalized timestamp of 11 o'clock, 11:15, 11:30, and that's repeated for each one of my tags that I have. So this is kind of the most important query that we see people use to get tag data 2. It does have the ability to return 1 million values within a single call, so you can load that up and request away.
Perfect. Thank you, Ken. And that leaves us on our final part of our sprint this afternoon. Lenny, now we've shown how to bring this information over as into an OPC server. We've shown how to go direct to a source like Canary, bring in the raw data or the aggregated data. Lenny, if you'll touch, please, on the fact that Flow has been a bit of an aggregator of data sources and now some of the power you can do using Flow's API to reach not just the information Flow has, but also the data that's inside of those sources.
Perfect. All right, so we ended up building our little visualization based on the Flow server, and it is also the Flow server that hosts the API endpoints. So if I expand my Flow server here, I can go and say, let's just open up the API documentation. So if I click on the open there, it will give us a Swagger documentation around Flow's API. So I can get the configuration components that's within Flow. I can get that back. That this will include my calendar config, specific configuration for each calendar. I can get back the aggregated data for my events. I can get back the aggregated data for my measures. And I can get the raw data for my tags as well. Again, we'll play a little bit with these guys here. And then I can also get information back about my dashboards that I've created, as well as the model. So what is the folders that's within Flow? And I can actually reconstruct this entire model that I've built here. I can reconstruct that model in a different application by using the model endpoints that we have available. I like the search one. This is quite cool. So I can search within Flow anything around the model or anything around a aggregation method or everything around a template. And I can ask the Flow to go and find me anything that matches a specific query parameter. I'll show you guys how that works as well. Now, you can go and execute all of this within the Swagger documentation as well. What I've prepared for today is I'm utilizing a tool called Postman. And you'll notice that within Postman, I've got a collection. And within the Postman collection, I've got all of the endpoints that Flow has available. Now, I did not build this by hand. So I just want to show you guys a very cool way that I can automatically build that collection from Flow's Swagger documentation. So you'll notice that we do have the Swagger documentation available in a JSON format as well. So if I click on that link, it will go and show me all of the JSON documentation for all of our endpoints as a document. So if I copy this, go back to Postman, and I say, you know what, let's import a new collection within Postman, I can go and specify a link for the documentation. So paste the link in there, hit continue, and it will go and import this documentation for me as my Flow API. I'm going to go and say import here, and it will tell me my original one already exists. So I'm just going to import this as a copy. I don't want to break anything, but you'll notice that it will import that collection with all the endpoints that's available for me that I can then just go and execute within this tool. So that's quite cool that I have that capability to load that documentation from there. Okay, again, we use Bearer authentication to authenticate. So we've got the authentication already set up at the base level. So I've got my token that is generated by Flow embedded into the core as well. So let's look at this search API. So in the search API, I can go and specify, you know what, go and look within the Flow model and see if you can find anything that has the word evaporator with it. All right, so let's send this request out. It will go and look into Flow, and it will say, yes, I find quite a few things. So I found a template folder that has the word base evaporator within it. So if we look back into Flow, if I go to my templates, that's true. So there's the folder called base evaporator. And the nice thing about it is that it tells me, listen, it matched the component by name. It matched it on a template folder level. And this is the API call that you will have to do if you want to get the config for folder 10. So it will automatically build you those endpoints. So if I go down to a point here, so here it found a name match on a event. So this is our evaporator 001 batch event. And guess what? There we go. If you want to pull the data for this event, it's equal 14. And if you want to pull the model component it will automatically populate you with these 2 points as well. So what I can do with that now is I can obviously go to the data endpoint, look at a specific event, and in this case, guess what? I'm going to use event ID number 14, populate it in there, and I'm going to send this out, and it's going to bring back evaporator batch number 14 for me. And what it does is, because I did not specify a start and an end time, it's bringing me the last event that fired. I can see when that event kicked off, what's the duration of that event, and what was the quality of that trigger that we got back from the control system. But if I look back at flow, what about my batch, sugar, and upper spec attributes? I would like to get that back as well. So yes, I can go and say, you know what, please include all the attribute values as well. Let's send that out again. And what that's going to do is now say, okay, cool. For my batch, let's include the upper spec value. So there's the upper spec, there's the value, there's the sugar content and its value, as well as the batch ID and its value as well. Okay, so I can get all of that data available as well. Now let's look at something quite cool, and this is the call for tag data. Okay. Now, this is exactly the same call that David used within OPC router to get the tag back. And you'll notice that we can either specify a template ID or a normal ID. Okay, so let's just quickly have a look in Flow around that. So in my template within Flow, if I open up, let's say, the power template here, the power template's ID is 135. So every component within the Flow model has a unique identifier, in this case 135. So if I go back into Postman and I go and change this to bring everything back for template 135 or 136, doesn't really matter. Let's do 5. Let's send the response. And now it's going to go and say, okay, this is the first instance that I found from this template, which is evaporator 1. But I've also have another one. So by specifying one template ID, it brought back the 2 instances that was derived from this, ID 136 as well as ID 137. And I can get all of that data within one place. Postman is quite cool. You can write a little bit of scripting within it that you can actually visualize it. So very similar to Java's JNason kind of capability. We can also write the little thing just to extrapolate the data and see what the data looks like within Postman as well. So that's quite cool. But the cooler thing than that is I can now actually get raw tag data. In this case, the data for the temperatures coming from Canary, right? So the result that I'm getting back here is technically back from the Canary historian. But I don't have to only get back data from Canary. What if I want to get the data back potentially from my sugar content? Remember the sugar content, the specs, the upper and the lower specs. This upper spec limit, this doesn't come from Canary. This comes from the SQL database. And this ID is number 147. So instead of asking for a template, let's ask for a specific ID. In this case, ID 147, and let's send that out. Oops, something didn't work. Cool, so let's do, sorry, I'll just have to figure out what that is. But the point is that I can now ask for multiple tags.
You're under measure ID instead of tag ID, I think.
That's the problem. Sorry, thanks. 147, right? There we go. Thanks, Jeff. Cool. So this is now the data coming from my SQL database. Okay, but this is the cooler part. Let's add another tag ID. Let's add tag ID for something that does come from the historian, which is the actual sugar content. So tag ID 148. So let's add another tag ID there for 148. Let's send that out. Now in one return, I get data back from SQL as well as data from my Canary historian with the exact same formatting of that data. So your front-end application doesn't have to care where it's coming from. You have one way to format the data and to represent the data, which I think is pretty amazing if you think about it. So and 2 different data sources, normalized, pitched together within one JSON payload for you then to consume.
And this also, Lenny, could have been a tag that was a calculated tag where you've applied your data cleansing rules.
Correct. So I can go and take this little calculation that I've done here for the band filters, which is ID 141, and I've could have included that as well. So yes, Jeff, your calculated tags, let's just change this one. I can also go and add and bring back my calculated tag results into the call as well. And it will go and do the calculation in the back end, get all the data that's required for that, do the calc, and then spit out the result for us. 100%.
Awesome. So we've got single endpoint access here to be able to not have to understand the underlying data sources, not have to know how to interact with them, but be able to call them, and not just one at a time, but by scale because of the template ID functionality, and say, hey, anywhere in the model that I've got an evaporator, bring me back the raw data for weeks or days for these tags. And the end user doesn't have to understand what historians underline and what SQL databases, or they just know that they can get one feed from multiple sources. Okay, guys. Lenny, I'm sorry, I don't want to cut you off, but I think you're at the end.
That is it.
And we're at the end of time. We've got our 5 minutes left. We've finished. Guys, I'd like to congratulate you. You realize every single piece that you demonstrated, you did exactly on the time scale that you said you would do. In fact, I added 3 minutes of questions, and well done. Audience, final call for questions. We're getting ready to wrap, but here was the entire breadth of the project spread over 2-hour sessions. We've done a lot. I cannot thank you all enough for that. Let's do an update on pricing, because Dawood, you extended the functionality of OPC router from what we used last week. Walk through that, please.
Yeah, so basically, because we added another feature, which was the REST call feature, we could, in the perpetual mode, add that as a perpetual module, but I just thought, to be funny, well, that's kind of crossing that line now, saying, well, maybe you should look at a subscription approach now, if that's the approach, and you get so much more. So we just illustrated what the standard subscription price would be, and included in that is other MQTT stuff and Sparkplug stuff and all the databases things, etc. So pick and choose and use whatever you want.
Yeah. So we updated year 1, year 2, year 3 pricing, but look, everybody, based on what you've seen, all of the functionality that you've seen, there's no gotchas on this. So what Ken demonstrated is all part of that price. What Lenny demonstrated is all part of that price. The API access, the contextualization, all of the calcs, the dashboarding, the tool. I mean, it's all in there. And you're talking about maybe 1, maybe 2 people being part of your management team internally on this. Guys, we've been answering the questions as we've been going along. I don't have any questions pending. Well, I say that. Let me double check and make sure I don't. Lenny, there was a question I had just answered that we never really brought up, but Keith had asked about when you had originally queried the SQL data source. He had some questions just on, is that something you have to do every time you need that data brought back from SQL, or is it something that Flow will do automatically once you've made that connection? You might still be on mute, Lenny. Check your mic, please.
So we will continuously, you write that query once in your template. We will then, the Flow engine in the back end will continuously poll when it's necessary to pull the new data that's available. So it's something that our engine handles in the back end automatically. Also, if your users are not too familiar with writing queries, we do have a capability where we can take a database schema and kind of build a tag namespace and that will kind of automatically build some of the queries and do replacements of some of the parameters automatically. So then it becomes a tag that you just drag and drop within your model. So then your user don't have to worry about the script or the SQL query that sits in the back end at all. But someone has to define that query in the beginning, but after that, Flow will take over and execute that periodically as it needs to.
Perfect. All right. Well, Ken, Dawid, Lenny, thank you so much to our audience. Thank you for your continued support. Our next event is going to be on August the 7th. We're going to take take a break for the summer as everybody's on holiday or traveling, it seems. But we'll be back on August 7th. More details to come on that shortly. And this and the previous week's session will be on our Integrate Live YouTube channel, hosted for you to watch, rewatch, share, and comment on. Everybody, thank you so much, and I hope you have a great rest of your summer. We'll talk to you soon.